Welcome to the class of quantitative structure activity relationship predictions. Quantitative structure activity relationship is an analytical application that can be used to interpret the quantitative relationship between the biological activities of a particular molecule and its structure. In simple words, the quantitative structure activity relationship means nothing but there is a relationship always exists between structure and function. So if two compounds are having similar structure, then probably they may have a similar function. So on the basis of this only, the quantitative structure activity relationship is working out. And here, by using this quantitative structure activity relationship, we are going to virtually screen the database of chemicals to identify few chemicals which are having similar structure to the drugs. So for that purpose, we are going to use this qsar, and for qsar screening studies, we are going to use the chemoxon tool from ACD Labs website. And this chemoxon tool is going to contain two parts. One is a JChem, another one is the Marvin beans. The JChem is going to have the command line tool of ScreenMD to screen the chemical databases, whereas the Marvin beans is going to have a software like Marvin Sketch, Marvin View, and Marvin Space, which are used to visualize the molecules and draw the structures and correct the structures and see the chemical libraries and all. We can use this Marvin Sketch and Marvin View. And then Marvin Space is used to see the three-dimensional structure of the protein. So this is the package of chemoxon. So both the packages are actually installed already for this class. And if anybody interested, they can download it and they can install from the ACD Labs website. Okay. So now we will see how, by using this JChem, how we are going to screen the chemical databases which are already we created in the chemical library creation classes. Okay. So now we will see this tool. So before going to this quantitative structure activity relationship preparations, we need two files. One file is that drugs.smiles, the other file is the chemicals.sdf files. So I hope everybody knows that we already created the chemical SDF file, and you should know how to create this drug.smiles file. As we saw earlier, that is, we will go to the drug bank, and from the drug bank, for each drugs what we are interested, we can collect the smiles by clicking the smile icon, and from this smile, you just copy the smile, and then you go to the folder where you want to run this program. To run this chemoxon program, we actually installed the program in D, chemoxon and JChem folder. So in this folder, we should go to the bin folder. Within the bin folder, we have to create a file as drug.smiles. We have to create a file which is known as drug. So we have to create a file which is known as drug.smiles. Okay. So we have created the file which is known as drug.smile. So then we should open this drug.smile file by using Notepad. Let us open it. Okay, open with the Notepad, and then you paste the smile of a drug. So after collecting one drug, you go to the again a drug bank database and you collect the smile of the second drug with nowhere. As usual, you go to the drug bank page and you paste the name of the drug and you search the database and you will get the link of written over, and in the page you click the smile option and you will get the smile. You copy the smile and you come back to this file and then you just enter and then you paste the smile. So this is how we can create the smiles files with the smiles of the drugs. So if you want to select 4 drugs for a study analysis, you collect 4 drugs. If you want 10 drugs, you can collect 10 drugs. So as the number of drugs increases, your output is also bound to be increases. For the present example, we have collected the smiles for these 4 drugs, and then it is placed in a notepad like this. This will contain 4 drug smile formats. So if you save this file, and if you want to know whether the file is created properly, you can open this drug.smile file by using this Marvin view application. I already told you that this Marvin is installed along with this JCAM. So once you open this file, you can see the structure of the 2 drugs. We saved the file in smile format. Now you can see the structure of the smile. So similarly, for all the 4 drugs, we created a file which is known as drugs.smiles, and it will contain the 4 structures of the drugs. So we created 4 structure of the drugs in this file. Okay, then we already created another database file which is known as chemicals.sdf, and it will be contain around 970 molecules are present in this particular database. You can see those chemicals in the database. If you go down, you can see the total number of residues which is present in the database. So it will take time to load. So once the loading is completed, you will see around all the chemicals which are available in the database. It's around 900 something, 978. This file contains 970 molecules are loaded in this particular file. So the chemicals SDF is ready, and then we also have a drugs.smile file. So these 2 files are created. Now we have to run the chemaxon. So to run this chemaxon, you need a command program, and for that purpose we will open a command line. So for this purpose we are running this JChem manager. Just keep on loading. The chemicals things are containing around 168 molecules are loaded already. It will take time to load the other molecules also. In this particular chemicals.sdf file, we have different molecules present in this. So we'll close this file to run it in a. So this is what it is today. So now we are going to the command line, and we are in the chemaxon JChem bin folder. In this folder, what we are having our own files like chemaxon JChem bin folder. We have chemicals.sdf file and drugs.smiles file. So now we will type the screenmd command to run this program well. So the command for running this program is actually present in this folder, that is screenmd command. So this is the screenmd command which is used for this program. So this is the screenmd command. Actually starts with the word screenmd followed by the SDF database chemicals.sdf, then followed by the smiles file drugs.smiles, and then you should have parameters like G or is having K, then you have PF -KCF -k mass -k bcut -tpsa, and then the end of this file will be -g -o table dot hits.txt, and then -o sdf hits1.sdf, and then here also we will put hits1. Okay, so this is the command which is used for running this qsar. So here you can see this screen empty term followed by the database, chemical database, followed by the SMILE file, and then these are represented as molecular descriptors. PF means pharmaco fingerprints, and CF means chemical fingerprints, mass the molecular weight, bcut is the size of the molecules, and the TPSA topological polar surface area. And by using this descriptors, we can screen the chemical databases by using this command. And then this part is actually represents about the output, how we are going to get the output. We'll get two output, one in the text file format, another one is the SDF file format. So after typing all the parameters, you can just enter. If everything goes nice, you will get again the command line without any error. If any error arises, it reports the error. If there is no error arises, it goes to the next command. See now, the program is going to be ended without any error. And in this folder, you can see now in the bin folder, the two files are created now. You can see this hits1.sdf file and hits1.txt files are newly created. And if you open this files, these two files, you will see how many number of molecules are selected for this studies, and they are reported here. So around 167 molecules are reported for the study. Of this, we are getting as output of 58. I hope 58 molecules are going to be selected by this virtual screen. So out of 970 molecules, we have selected only 58. 58 molecules are selected for the studies through this qsar virtual screening method. See, around 58 molecules are selected through this virtual screening. And then if we have this JChem as a commercial tool, we can also use other parameters like we can use this log P and log D, heavy options, and hydrogen donor, hydrogen acceptor options. And these are the parameters can also be used to screen the databases, and it has a few more applications also there. So what we are seeing here in the command is very simple command, and if we have a commercial version of this JChem, we can use it on a more complicated in the sense that we are going to get the best output of virtual screening if you have a commercial format. And when you are not having commercial format, when you have only the academic format, we can run, and for demo purpose we are using this simple screen empty command for virtual screening. So after running this virtual screening, out of 970 chemical molecules, we reduced it to 58. And if you see these molecules properly, the molecules will have some extra structures here. So these structures can be removed. So if you remove those type of structures which are having additional molecular structures, and this 58 might be reduced to 5 or 10. So like this we can reduce the number of hits, and after reducing the hits might be used for the further drug designing or docking purposes. So now in this part we virtually screened the chemical databases by using quantitative structure activity relationship method. Thank you.